For problem 10.4, we're looking at three different forces and how they're applied. There is one force here, 11.9 newtons. It's applied straight toward the center of the circle. There's another force over here, 14.6 newtons, that's applied at an angle there. And there's a force, 8.5 newtons, that's applied directly along the line that is perpendicular to the radius. You can see the radius is right along there. So we have to find what's the net torque. Well, this one over here is applied exactly perpendicular to the radius, so that torque is going to be 0 because the radius and the force are parallel to each other. The one in the bottom here is going to be exactly perpendicular to it, so its torque is going to be the radius times the force. So that's going to be 8.50 newtons times 0.35 meters. And it's going to make it turn in a counterclockwise direction. So that one is going to be positive. When we multiply those together, we get positive 2.975 Newton meters. But the one that's on top here is going to be a little bit different. Okay, this one is at, you can see it's at an angle. So to calculate that one, we're going to have to take our F sine of theta. Okay. And the theta we're talking about here is going to be the 40 degrees. Okay. So it's going to be 14.6 newtons times the same radius, 0.350 meters, times the sine of 40 degrees. Okay, remember, we want the component that's going to be perpendicular to the radius. When we solve all that, we get 3.28 Newton meters. But notice that one will make it turn clockwise, so that will be a negative one. So then we got to put those two together. We have negative 3.28 Newton meters, and we've got plus 2.975 Newton meters. Put those together, you're going to end up with negative 0.31 Newton meters, or just 0.31 Newton meters clockwise, because it's a negative torque.